Lesson 25, age and rate problems. Do I have the attention of my guys in the back? All right, so we're locked in. I don't know about that. Don't know about that. All right, if I have to talk over you, I'm real quickly going to get ticked off, and that won't be a good thing. All right, age and rate problems. So we're basically, I mean, your book has probably got some examples, but there's not really, with the rate problems there is. The rate problems are going to stay consistent. The age problems are like a lot of different things that we've run into. You have to read and be able to write an equation from this, okay? So what I'm going to do is I'm going to go ahead and skip over to a blank page. You guys have this page sitting in front of you, correct? Right, I think I hit record. I think my voice is on. So we're going to go ahead and skip over to this. Now, the question reads, Tom is 6 times as old as Todd. In 4 years, Tom's age will be 16 years more than 3 times as old as Todd. How old is Tom? Right, really kind of crazy out there question. First thing I'm going to do, because we want to use variables for names, but both of them start with a T, is let's do something else. Let's say the first name is Tom. Let's make Tom X. Let's make Todd Y. Okay? So we got Tom and Todd. Now, what's going to drive me crazy today is I think with the construction out there, it's got my board like wobbling all over the place, and like I'm almost seasick. But anyway, all right, so let's keep this as simple as we can. Tom is 6 times as old as Todd. Okay, so in math, is what? What do we substitute with is? Equals. All right, so Tom is X. X equals what? 6 times as old as Todd. So it's 6 what? 6y. That's pretty easy so far, right? Let's keep it as easy for as long as we can. All right. In 4 years, 4 years from now, what happens to your age as you go forward in time? You get older, you are adding. Okay, so we have to, so long as we understand how age works, it's really not too bad. All right, in 4 years, Tom's age will be. All right, so what we're going to do is x plus what? 4. Tom's age will be 3 times, or will be 16 years more than. All right, so is it going to be equal to? No, what do I have to do? Am I subtracting 16 or adding 16 to get it equal? Okay, so we need to subtract 16 from this side or add 16 to the other side to keep it equal. All right, so in 4 years, Tom's age will be 16 years. We could say too much, but in any case, 16 years more than 3 times as old as Todd. So 3 what? 3y, okay, or 3 times y plus 4. And you have to keep that in mind because 4 years from now, who else is getting 4 years older? Todd is also getting 4 years older. Okay, we're moving in tandem. Okay, so we can change this to be x minus 12 equals 3y plus 12, right? Okay, hopefully I'm doing all of this right. I haven't actually looked at my notes. Okay, so far all looks good. Oh, did I mess something up? Okay. Do we want this in slope-intercept form? If we plug it in as slope-intercept form where we get y equals, keep in mind, what do we actually want to solve for? We want to know how old Tom is. We want to solve for x. Okay? All right. So here we've got x minus 12 equals 3y plus 12. We could, actually, in reality, we kind of want to solve for y. Because if I can plug y back in, that's going to solve for x, correct? So if I solve for y, I'm getting to x faster. But let's just do how we would probably naturally do it. We would probably add 12 to this side, right? We would get x equals 3y plus 24. Okay, that's what we're getting there, right? So if I came up here, right, now I'm getting 3y plus 24 equals 6y. Subtract 3y. Okay, so 24 equals 3y. Divide by 3. Y equals 8. Okay, now, right, what's 6 times 8? X equals what? 48. So how old is Tom? Tom is 48. Okay, now we probably could have got there a little quicker if we'd done this differently down here. You know, if we just solved for y like I said. But there we would have had to have subtracted 12, right? That would have given us x minus 24 equals 3y. We would have had divide by 3, right? We would have wound up with a complex equation. We would have gotten, 1/3 x. So I don't think that what we actually did was harder than if we had just gone straight to y, right? Does that make sense? So I will stand by our first go through because we wound up with no fractions. Okay, our answer is still 48. Do we understand what happened? It's not a lot different than our equations that dealt with nickels, dimes, and quarters and all that kind of stuff. Okay, we're just dealing with age. All right, your next question. Ben is 5 times more than, I'm sorry, not 5 times, but Ben is 5 more than 2 times as old as Henry. So here we can use B and H, right? Okay, Ben is, so B what? B equals, is it though?
Well, it is equal, right?
Yeah.
But it is 5 more, which would be B minus 5. Well, to equal Henry would be minus 5.
Right, so let's start off with B minus 5. Ben is 5 more than. 5 more than what? 2 times as old as Henry. Now, our other way of writing that could have been, you could have written Ben is and just wrote 2H plus 5, right? Now I have B equals. Okay, they're equivalent, are they not?
Yeah.
We understand that. We haven't done anything too crazy there. So let's go with this right here. B equals 2H plus 5. Let's look at what else they give us. In 16 years, the sum of their ages will be 100. Okay?
Equal to 100.
B
Plus
16 plus,
2H.
no, 16 years from now, Ben's age, plus 16 years from now, Henry's age, will be what? Oh, not 2. Plus H plus 16 will be 100. Right? Okay. You probably could. Most of these you could at some point set up as a matrix if you put them in the right order. Right? So we'd have B plus H plus 32 equals 100, right? Okay, you could, so if you subtract 32, we got B plus H equals what? 68. So yeah, if you went back up to this equation and you subtracted 2H and you got B minus 2H equals 5, that's matrixable, if that's even a thing. But also what I could do is plug in 2H plus 5 here. So 2H plus 5, I'm substituting, plus H equals 68. I'm getting 3H, subtract 5 equals 63. Okay, what's H? What's 63 divided by 3? 21. So we need to find Ben's age, right?
Yes.
So all I need to do is go back up. What's 2 times 21? 2 times 21? 42. What's 42 plus 5? 47. And the 47 is what I want. I don't know that it says that they're hanging out. They could just be two guys that met at a gas station. They could work together. Yeah, it's absolutely possible. All right. 3, right? I think what we have 12 questions. We'll get through them as many as we can. Is it Tom and Todd again?
Yes.
Oh my goodness. All right. And so Tom again equals X. Todd again equals Y. And these are really, they're just practice. The more of these that you do, the more comfortable you'll feel with them. Okay? So Tom is 3 times as old as Todd. That's really straightforward, right? It's not 5 more than 3 times as old, anything like that. X equals what? 3Y. Great. Thank you, question, for keeping it normal, where I'm not having to add or subtract from one side or the other. Okay? In 4 years, Tom's age will be 4 years more than. Okay, now they're throwing the curve, right? All right, so what are we doing with Tom's age? We're adding 4. What are we probably going to do to Todd's age? We will see. We'll get there. In 4 years, Tom's age will be 4 years more than 2 times as old as Tom. So we're going to subtract 4, right? Now we can set them equal. 2 times as old as Todd. 2y. 2, keep in mind this, because you can't just put 2y plus 4, right? You'll end up with the wrong thing. His age is plus 4. Okay, so we've got x, what? I mean, just x, right? X equals what?
2y plus 8.
2y plus 8. Okay? Solving for Todd. Solving for y. Okay? Plug in what? So we could plug in 3y for x, right? So we can say 3y equals 2y plus 8. Okay? So subtract 2y. Y equals 8. We didn't say Todd's 8 years old. Yeah. Okay. Why is it terrible? It could be his dad. It could be his uncle. It doesn't have to be weird. I don't know why you're making it weird. Shh. Okay. Question number 4. Now things are kind of changing gears here. We're not into age anymore. All right. So train A leaves a station traveling 64 kilometers per hour. 8 hours later, okay, so he's heading off. 8 hours later, okay, train B leaves the station. Okay, he's going 64 kilometers per hour. Train B is going 74 kilometers per hour, right? The question is, how long will it take train B to catch up to train A? Okay, so this is this, okay? We're going to use X in terms of time, okay? Okay, so this is, our rate here is 64 kilometers per hour times an unknown number of hours, right? Well, yes, because he's been traveling for 8 hours. That's a good point. I was just going to do that later. All right, so 64 times 8 is how far it's already gone. Train A has gone before train B leaves. Does that make sense? Okay. Plus, it's continuing to travel at 64 kilometers per hour, right? Right, we don't know how long it's going to travel at that speed before train B catches it. But we do know, because we want X, X is going to be the same time for either how fast is the other train traveling. 74 times the same number of hours, right? Because X is just representing those number of hours that B is traveling for. Okay, so that's all the equation is. Does the equation seem a lot simpler than what the question seemed like? Yeah. Does this make sense? Could we do this? Could we write this? Could we read that question and come up with this? All right, what's 64 times 8? 512. Oh, I'm sorry. Well, what are we going to do with the 64x? Subtract, so I'm getting what? Oh, darn it. Equals 10x. Okay, divide by 10, right? 51.2 hours. 51.2. Yep. So in 51.2 hours, train B will catch train A. Takes a little bit of time because he's only going 10 kilometers per hour faster. So every hour he catches up 10 more kilometers. But he's okay. All right. So we get this question hopefully.
No, it's a little faster. Because 60 miles per hour is 100 kilometers.
Yeah, but if you're going 64 kilometers per hour, you're only going like 40 some miles per hour. Whatever it is. Okay. All right, let's keep moving on here. Let's see. Now, this is where things get a little bit more consistent in terms of rate questions. Okay. Question number 5. Okay. All right, so driving a tractor, Larry can plow a 1-acre field in 6 hours. Sarah can plow a 1-acre field in 12 hours. If they work together, how long will it take to the nearest hour? Will they take to plow a 1-acre field? Okay. I don't know how many bottom plows, what it is. Okay, so we're going to deal with it's what we call rate times time plus rate times time equals jobs because we have 2 people. Okay, anytime you get a rate question that involves 2 people, this is your formula. Okay, so we have to look at our first rate. Okay, our first rate is 1 acre. Okay, so we're going to do acreage over time per 6 hours. Okay, plus 1 acre over 12 hours. Okay, and so what we should get is a time for our jobs. Now, 1/6 plus 1/12, what do we have 2 fractions, right? Common denominator, our common denominator is 12, right? I should be getting 2/12 plus 1/12, right? I get 3/12. So that's together, they can plow 3 acres in 12 hours, right?
Yeah, so 4 hours.
Right, so that is 1 acre every 4 hours. And that was the question, is how long would it take them working together to plow 1 acre? They could have said, how long would it take them working together to plow any number of acres? We would have had to use this. So if they said 2 acres, we would have gotten 8 hours. But because it worked out with our rate, 4 hours is their rate to plow 1 acre together. Okay, does that make sense? Rate, this is the big part that you want to know, though. Rate times time plus rate times time equals jobs. Okay? All right. No, okay, number 6. Let's see if I can get over here. Number 6. Now, this is the formula that we'll use when working with a group of people or things. Okay? Number 6, while building a new apartment complex, the work crew found that it took 6 people to frame 5 apartments in 7 hours. The foreman added 8 more people to the job. How many hours would it take them to frame 60 apartments? This is going to take the same set of steps almost every single time. They really don't mix it up very much. So my formula is rate times workers times time equals jobs. Okay? Now, every single time they will not tell you the rate. They will tell you how many workers you have. They will tell you how much time it took and how many jobs were completed. Okay? Every single time. How many workers do we have working on our crew?
6.
6. How much time did it take them? 7 hours. And how many jobs did they get done? They got 5. Okay? So we're going to get rate. Let's see. 6 times 7 is what? 42. Equals 5. Divide by 42. What is my rate? What's 5 divided by 42 simplified? Is it just 5 over 42? Okay. Yep. 5 over 42 is it. So just like, if you'll think about this in terms of, remember our direct and inverse variation stuff, right? We always solve for k first, right? And then they give me new information, but I plug k in and I solve for whatever's on the left-hand side every single time. This is just like that. Okay, I have my rate. My rate is going to go down as part of the next part of this equation, okay? Because my rate's not going to change. Now, what did they do with the workers? Did the workers change at all? They added 8 more people. We had 6. We added 8. How many workers do we have? 14. So we've got 14 workers. Now, on this next part, they will almost always ask you to solve for time. How long will it take with this new group of people? Okay? Now, how many jobs are we doing? 60. Okay? All right. So carrying this down, first thing we're going to do is 540 seconds times 14. Can you tell me what that is? Or reduces to? Should reduce to like 5/3. 5/3. Reduces to 5/3 t equals 60. Can I divide by 5/3? No, but I can multiply by the reciprocal 3/5. Okay, so I get t. Let's see, we got 180 divided by 5. Is it 36 hours? 36 hours. Okay, once you know the formula, which is this, anytime I'm dealing with a group of people working a set of jobs, this is the steps and format for these questions. What's that? Yeah, but once you know them, you use them all the time. All right, number 7. Okay, number 7. One machine can make 42 levers in 6 minutes. Another machine can make 24 levers in 4 minutes. All right. RT plus RT equals jobs. Let's see, potentially. Let me make sure that that's the case. Yes. Okay. Let's see. The second machine began making levers 2 minutes before the first began. How long will it take the 2 machines working together to finish 194 levers? Okay. All right, so what is our rate on the first one? How many levers did he make? Made 42 levers in 6 minutes. Okay. What's the rate on the other machine? 24 in 4, right? Okay, now, which machine began working first, the first or the second? The second machine began working earlier, right? By 2 minutes. So his t is t plus 2. This one is just t. Okay? So rate times time plus rate times time. And our question is, how long will it take them to make? Okay, how long will it take them working together? Okay. Well, honestly, what I can probably do is, what's 42 divided by 6? 7t. All right, what's 24 divided by 4? 6. So let's simplify as much as we can. This is, if I just do this, yeah, it almost works. If I just shake at the right level, it seems like it's not moving. Okay. All right, now distribute the 6. So I got 7t plus 6t plus 12 equals 194. Okay. Add those up. I've got what? 13t
Yeah.
equals, subtract the 12, 182. 182 divided by 13. My time is 14 minutes. Okay? The biggest part to these questions is knowing which equation I need to use. And then how to set it up. And then if there's a t plus or a t minus, make sure I put it with the right rate. Okay? Any questions about that, about this one? Okay? And we label. We label or we don't get credit. Okay? 8. Together, Juanita and Mark can make preparations to cater a dinner in 7 hours. Alone, Juanita can do the job 3 hours faster than Mark. Okay? Find the time that each person takes to prepare to cater a meal. Okay. Well, let's keep this fairly simple. Okay, as much as we can. Let's see. I want to go back to that. Together, Juanita and Mark can make preparations to cater a meal in 7 hours, right? So Juanita plus Mark equals what? 7. Okay. You went, huh? I was like, is there something wrong here that I don't know about? Okay. Let's see. And how I ended up doing this, I don't even know if I used this particular part, but if we do rate times workers times time equals jobs, we would get rate, workers are 2, jobs are 7, and actually, I'm sorry, time is 7, and they're getting, what, 1 job done? Okay. So look at it like that, just to find out what the rate would need to be. Well, that's going to be R14 equals 1, so the rate is 1/14th, right? Okay. So what we're saying is that 1/14th plus 1/14th would be 1/7th, right? 1 job, 7 hours. That makes sense, correct? Because 2/14ths is 1/7th. Okay? Now, let's look at what else we know about them. Is that Juanita can do the job 3 hours faster than Mark, but their average rate is still 1/14th, right? Okay, but we have to maintain the average 1/14th, but she's 3 hours faster, right? Which means by that notion, right? If she's 3 hours faster, we can't say 1/11. Right? Because that doesn't maintain the average. What you have to do is divide 3 by 2. Okay, what's 3 divided by 2? Is 1.5, right? Okay, so we're going to subtract 1.5 from 14. I think I'm doing this right. Maybe I'm not doing this right at all. Okay, what's 14 minus 1.5? All right, so 12.5. Okay, which would make, now you have to add the 1.5 to his time. Right, so that's what, 15.5? Now the actual answer comes out to something like 12.7 and 15.7, but I would take this. Okay? Does that make sense? Okay. All right. Not my favorite question, but all right. Number 9. 9. Oh gosh. Okay. Claire, working alone, can do 2 jobs in J hours. Joaquin, working alone, can do 3 jobs in K hours. They both have their own rates. How long will it take Claire and Joaquin to do 2 jobs if they work together? Okay, well, this is rate times time plus rate times time equals jobs, right? Okay, so let's look at this. Well, in that case, it's usually just T, right? So she can do 2 jobs in what, J hours? Okay. And he can do what, 3 jobs in K hours. Okay. So let's see. We're just, yeah, they're both just T. All right. So let's ignore the T's for a second here, right? Because it's basically I'm going to get 2T over J plus 3T over K, right? So if I look at it like that, what do I need to do? And what? How many jobs do we want to get done? 2 jobs? 2 jobs. Okay, 2 jobs. I need a common denominator, right? So I'm going to multiply by, what do I multiply? K over K and J over J. J. Okay. So we have 2KT plus 3JT all over JK. Seriously. Okay. Let's see. We're gonna factor out, because we want to solve for t. We're gonna put that t to the outside. Okay. So because to solve for t, now what do I need to do? Multiply by the reciprocal. So the reciprocal. And so I'm going to get 2jk over 2k plus 3j.
So when you flip for your reciprocals, your plus don't
No, no. You're thinking of multiplying by the conjugate. We're not doing that here. Yeah, it's an algebraic form of it. And being able to do this means that if they were to give me the information, we could plug it in and solve for the number. Right? So if they told me, okay, well, her J is actually this, and his K is actually this. Yes. All right, 10. 10. I'm trying to get through these, guys. 10. So you see as many of these as possible. Okay. This one I like. A plane flies 900 miles in 3 hours with a tailwind. Okay, so 900 miles, 3 hours. Okay? He flies back, but he's got a headwind now going against him. He's going to fly the same 900 miles, though, right? Okay? But it takes the same plane 4 hours to fly against the wind. Okay? What is the plane's speed in still air? It's the average. So what is his miles per hour with the tailwind? Well, 300 miles per hour, right? Right? What is his speed with a tailwind or with a headwind? What's 900 divided by 4? What's that? 220 225. All right. So, what's 300 plus 225 divided by 2? 262.5 is how fast he could fly in still air. Because one is pushing him, one is resistance. If we get rid of that, it's the average. Okay?
So it really takes 3.5 hours to get there.
With no air pushing or pulling. Yep. Okay. 11. Gracie's average driving speed is 15 kilometers per hour faster than Richard's. In the same length of time it takes Gracie to drive 348 kilometers, Richard only drives 288 kilometers. We want to know what Gracie's average speed is. Okay. So what we're going to start off with is Gracie's speed equals Richard's speed what?
R plus 15.
Plus 15. Good. Okay. G equals R plus 15. Okay. Rate equals distance over time. Right? Okay. Rate equals distance over time. Okay. All right. So let's see. Let's look at this question again and see what else we can figure out. In the same length of time it takes Gracie to drive 348 kilometers, Richard only drives 288 kilometers. So we want to know, what is the distance between them, right? She drives 348. He only drives 288. How much distance is there between them?
60.
There's 60 kilometers between them. Okay? So she drives how many kilometers faster than he does per hour? 15, right? So every hour she gets 15 kilometers further ahead. After this trip is over, she's 60 kilometers ahead. So if we take 60 divided by 15, we find out how long they've been driving for, right? They've been driving for 4 hours. Her rate equals her distance over time. So 348 divided by 4 is going to tell us how fast she was traveling, right?
87.
She was traveling 87 kilometers per hour. Does that make sense? Can we replicate that?
Yes.
Okay. Okay. Last question. Number 12. You notice how some of these are the same, but a lot of them are different variations, different types of things. 12. Okay, one machine. Okay, this is a machine. This is the same type of question we saw before, right? One machine is 20 levers, 4 minutes. 20 levers, 4 minutes. Okay? Another machine is 24 levers, 6 minutes. Now, we can reduce those, but let's wait on that. Okay? The second machine began making levers 4 minutes before the first. So what am I putting here?
Plus 4.
T plus 4. What am I putting over here?
T.
T. Okay? How many levers are we going to make? 160. And we want to know how long it's going to take them working together to get through the 160. All right, 20 divided by 4 is 5t. 24 divided by 6 is 4 times t plus 4 equals 160. Distribute, so I got 5t plus 4t plus 16 equals 160. 9t plus 16 equals 160. 9t equals 144, I'm told. Divide by 9. T equals 16. All right. So there you go. Any questions? You guys have questions 1 through 12 for your homework. You're welcome. I don't know.